Hello everyone and welcome. In this lesson we're going to be finding the zeros of a polynomial. Now the zeros or roots of a polynomial are usually thought of as the points at which the graph of a polynomial intercept the x-axis. And when you hear the expression solve a polynomial, what you're being asked to do is find the zeros of the polynomial, find the x-intercepts of the function's graph, or to find the value of x for which the function is equal to 0. Visually, these are the points we're finding. Now, several strategies exist to find the solutions to polynomials, including factoring, finding a GCF, factor by grouping, synthetic division, etc. But we're just going to focus on the first two strategies in this list for this lesson. Factoring. First, we begin by setting the equation equal to 0. After all, we're finding the values for x for which the function is equal to 0, so we're going to go ahead and replace that f of x with a 0. And then find numbers that add to give us the middle term and multiply to give us the last term. -3 and -2 will do the trick, and I'm going to go ahead and write my polynomial in factored form. Once we have it in factored form, we're going to set each factor equal to 0 to solve it. Add 3 on both sides, add 2 on both sides, and I've found my solutions of 3 and 2. Now for a problem with a greatest common factor. Here we have a polynomial with two terms, and they both have something in common. I'm going to still begin by setting the equation equal to 0, and then I'm going to find the largest factor of each term, or the largest thing that multiplies by something to give you each term. So in this case, 5 times 1 gives us 5, 5 times 2 gives us 10, and I can take an x out of x squared and x, leaving me with 5x times x will give me 5x squared, and 5x times -2 gives me -10x. Something written in factored form can then be solved by setting each piece equal to 0 and solving. In this case, to get rid of the 5, which is being multiplied by x, I'm going to divide both sides by 5, and to get rid of the -2, I'm going to add 2 to both sides, giving me 0 and 2 as my solutions. Now for a combination of the two strategies. Here we have one problem that's going to require both strategies. Once again, set the equation equal to 0. And then always look for a GCF first. In this case, there's an x in each of the terms, so I'm going to go ahead and factor that out. And then I notice something similar to my first example. In fact, it is exactly the same as my first example. And I'm going to go ahead and break that one up in the exact same way. Find two numbers that add to give me the middle term of what's in parentheses and which multiply to give me the last term of what's in parentheses, and write that in completely factored form. Set each of those factors equal to 0, solve for x, and we have our three solutions this time of 0, 3, and 2. Great. Now, sometimes the problems we work on can be pretty difficult to solve. So I want to give an honorable mention to something that will always get us out of trouble, the quadratic formula. If you have a quadratic equation, something in the form ax squared plus bx plus c, you can pretty much always use the quadratic formula to solve it. It's not really necessary for the problems we're going to look at in this course, but it's definitely a nice tool to have in case we ever want to use it. So here we have a polynomial equation of this form we're looking at, 3x squared plus 6x minus 4. And in order to use the quadratic formula, I need an a, I need a b, and a c. Now, a is going to be the first coefficient, or the coefficient in front of x squared when written in order of exponents. B is going to be the second coefficient, and c is going to be our last coefficient, or the constant of our function. I go ahead and plug the a, b, and c into the formula you see on the upper right-hand side, and then simplify. We follow the order of operations. We're going to do exponents first, 6 squared to give me 36. Then I'm going to go ahead and do some multiplication. Then I'm going to simplify what's in the square root. The square root is a grouping symbol, so you're going to always want to simplify what's under there first. In this case, I get about 8 1/4. And then to get two solutions, which a quadratic equation will have, On one side, I'm going to do negative 6 plus 8 1/4 divided by 6, and on the other side, I'm going to do negative 6 minus. When we see that fancy plus minus symbol in this equation, that's just a way to remind us that we're going to add to get one solution and subtract to get the other. Go ahead and add the top and divide by 6, subtract the top and divide by 6 to arrive at our two solutions, and we have solved this polynomial equation. Thank you. Hope this video is helpful and that you visit us again.